Welcome to our next video in our macromolecule series, carbohydrates. Before we get into the goodness of carbohydrates, there's a vocabulary we need to address, and that is of monomers and polymers. And we need to address this because not only does it come up with carbohydrates, but it also comes up with nucleic acids and proteins, which we will be dealing with later. So, a polymer is a long-chained molecule made of repeating units. And there are some interesting carbohydrate polymers that we're going to address. A monomer is the repeating unit in a polymer. And in carbohydrates, the monomers themselves have some very significant functions regarding life. So we have to address both. Now, carbohydrates themselves, a lot of the secrets of carbohydrates are trapped in the name. When we see carbo, we should be thinking carbon. And that's appropriate because carbohydrates have a lot of carbon in them, as all of the macromolecules do. However, the second half of the name, hydrate, that should be evocative of water, and the formula of water is H2O. So when you put the name together, carbohydrate, you have carbon, H2O. That happens to be the ratio of atoms in all carbohydrates. So you have 1 carbon, 2 hydrogen, and 1 oxygen. And that's it. That's the ratio. Lipids also have carbon, hydrogen, and oxygen, but they do not have them in the same ratio. Lipids are primarily carbon and hydrogen for very, very long chains or many, many rings, and then they've got a little bit of oxygen. Well, because carbohydrates have so much oxygen, instead of being nonpolar, they are polar. That oxygen does not share those electrons evenly. It's got a high electronegativity, and so they have partial charges all throughout the molecule. And that is what we see in carbohydrates. Because they're polar, they are able to dissolve in water, and that's significant. So let's start here with our first tier of carbohydrates, the monosaccharides. Mono means one, saccharide is a big fancy science word for sugar. So we're talking about single sugars. And sugars can be chains of carbon from 3 to 6, and they have a couple qualities. They always have 1 carbon double bound to an oxygen, as you can see here and here and here and here and so forth. And the other carbons all have a hydroxyl group, and this is how we maintain that 1-to-1 carbon-hydrogen ratio, is that we have each carbon is either double bound to an oxygen or bound to a hydroxyl group. You can also see that subtle changes in the orientation of the atom can result in different sugars. If we have the hydroxyl group on one side, we can get glucose, which is our primary sugar for respiration. And if we have the hydroxide on the other side, we get galactose, and a different sugar altogether. And so the properties and chemical qualities of these monosaccharides is dependent on their orientation of their double-bound carbon and oxygen, as well as the arrangement of their hydroxide groups. Now, in the previous slide, we saw all of these sugars in their linear form, but sugars can undergo isomerization, and they can change into a ringed structure. And what that is about is this carbon, this double-bound carbon, can curl over and react with this carbon. Now, with this hydroxide group, rather, to undergo a binding reaction to link these chains. Now, when this happens, we get the ring structure down here. Now, the ring structure is allowed. Let me go back. The linear structure is used for things like precursors to respiration. It can be chopped up. It can be moved around. When we need to destroy that sugar to do something with it, we often use this. The ring structure is for going in the other direction. When we want to build something bigger with the sugar, we go to the ring structure, because the ring structure can then be used to make bigger sugars. If we have 2 rings and they undergo a condensation reaction where we make water and unite 2 sugars together, we then can make our second category of carbohydrates, disaccharides. And disaccharides are dependent on the sugars, the monosaccharides you use to build them, and the arrangement of those monosaccharides. So in this case, we have made maltose here from 2 glucose molecules, and we have made sucrose here from a glucose and a fructose molecule. Sucrose is our sweet, sweet table sugar, which we enjoy putting on all our food because it is delicious. So disaccharides are made from monosaccharides. Monomer would be the monosaccharides. The disaccharides are not quite polymers yet because they are linked together, but they are not long chains. A polymer has to be a long chain. And we're going to get to polymers in Carbohydrates Part 2.